samo par besed o Anni Olszewski, to je kustosinja, pedagoginja iz Krakova, iz Poljske, poučuje na fakulteti za humanistiko. Tu vodi program restauriranja medijskih umetnosti Resensor Lab. Trenutno se ukvarja s področjem strojne estetike in pa razvojem institucionalnega okvira za kreativne laboratorije konzorcij HAL Labs za Horizon Crea. Tako da deluje kot rečeno kot raziskovalka. Njeno najnovejše delo, ki ga je ravnokar dala, vendar čaka še na publikacijo, z naslovom Not a Book on Images, Experiments in Image Processing and Machine Vision. Bo išlo prihodnje leto, tako da tukaj nam bo danes predstavila v bistvu raziskave, te zadnje raziskave, ki jih bo tudi izdala v tej publikaciji. Sicer pa se ukvarja v bistvu z strojno estetiko, strojno optiko, potem govorila bo danes o politiki tehnološkega zaznavanja, se pravi o temu, kako se današnje v bistvu senzorično dojemanje, doživljanje spreminja zaradi tega, rečemo, tehnološkega strojnega pogleda. Mislim, da bo tudi navezala tematsko, da se bo navezala na problem oblikovanja, materialnosti in tako da, kar mogoče vabim Anno, firstly I say, hi, we are welcome to host you here. I just did a short introduction on your research domain, but you are going to explain more in detail, address certain topics which you are researching right now. I also introduced your book coming out.
Thank you. Żywo, dzień dobry, good morning. First of all, thank you so much for having me here. It's a great pleasure for me, and thanks for a kind introduction. And I hope that we can follow up today's meeting, this week's meeting, with some other exchange and maybe actions that we take in relation to like technologies and design. And actually here I may introduce the aim of my talk that I've prepared today, which is rather practical, I would say, because I would try to persuade you for some kind of overhaul, reconstruction, maybe restructuring of the academic curriculum in arts and design in relation to machine vision and technological sensorium. So the technologies of sensing and politics of these technologies are going to be like our main topic today. This is based, as Ursula has mentioned, on my recent research, which is on engineering approached as an experimental trade. And if I were to speak about politics of technologized sensing in machine vision and express, like today's lecture's main line in one piece, I would say that it may go something like this. Designers have some ability, some power to counterbalance the hegemony of AI-driven capital, data capital. But this is unlikely to happen unless. So let's go into this. For a start, like let me begin this like discussion on the power of algorithmic gaze and design with like common places from which we usually start when we speak about this area. Sensory technologies and automation. So there is a wealth of scholarship revealing the ontology, capacities and limitations of the sensory technologies studies that show how effectively actually this automated gaze can control the environment and the behavior of the individuals that found themselves within it. So starting for like these famous studies that gave us actually the theoretical undertone for this area, we can say about like Georges Chamayou, the theory of the drone, where he speaks about algorithms that actually operate on the basis of daily life patterns, regularities of our behavior. Then we can go also to and I would like to also relate to Mark Andreevich, automated media, in the points in the parts of the study where he speaks about preemption as also as a technological rule for the algorithmic gaze and automated media for the control society. And from these theoretical studies, we may also go to critical code studies, urban data studies, like for example Rob Kitchen and others. Then we can also speak about the interventions, like artistic and creative activistic intervention that show how this milieu of technologized sensing in particular operates. And here you have very beautiful, very nice examples also here from Slovenia, from Ljubljana, from Axioma Gallery, for example. Sanela Jahniš, we've been talking about like her recent study and her recent project, who showed us how specific examples of society functioning under the calculative gaze happen. We have such projects like other ones. I would remind Drone Aviary by Superflux, the stealth and camouflage, civic stealth and camouflage studies and intervention by Adam Harvey. They are also very often quoted, like related to or we have films and that are based on the speculative architecture concepts as ideas. For example, there is a project, in particular when we speak about the vision technologies, there are among these projects we have Liam Young's city can where the city can see. Oh, welcome. Come in. And then we can go to electromagnetic situationist, critical engineering. So there is really lots of resources that can actually show us how this area of algorithmic sensing is functioning. What are the limitations of it, and how far it can reach into our daily routines. But what I feel that is somewhat less covered in these studies is the process of integration of these systems, the algorithmic gaze systems, for example, with the environment they operate in. So let's take a step back. That's why I propose right here with this talk, and look how those technologies are being marketed and how they are being integrated into the physical environment. What is the practice and what is the discourse around this process, like before they happen, before they start to function around us in our environment. So here, the idea is that this possibility of counterbalance I've mentioned about between data technologies and design or material engineering, it becomes well, even more palpable when we look how the vision is integrated into environment. And this we can do, the process of marketing, the marketing strategies and the process of integration. Like this is a large topic, but I would like to take a few examples I've looked at during my research. which come from the discourse of Fraunhofer Gesellschaft Institute, which is a union of scientific institutes, engineering institutes in Germany, offering solutions for industry companies, highly advanced technological solutions tailored for specific needs of industry. And also another area, another set of texts that I've been looking at, these are the, let's say, webinars and publications of one of the companies that has been recently, a few years, acquired by Hyundai Automotive Group. And I'm speaking about here about Boston Dynamics, which is one of the most visible parts, let's say, of this Hyundai group right now. So when it comes to selling technologies and how they are being well marketed and advertised, there are some specific terms that come to that enter the discourse from the different perspectives, but interlace in some way. So to like structure it a bit and simplify it a bit, we can say that in terms of vision, which we're gonna focus on, we have a like vision as a tool. Vision is being marketed as a tool, or vision is being marketed as a service, or is being treated as a resource in this technological industry sector. And it is obviously, it is not, the vision is not specific for these types of marketing and these types of discourse, because we know that most of these applications running on our devices, they are being marketed as a service right now. Yeah, but it also comes to the, when it comes to the vision, there are some more specific terms and conditions that are combined with it. So Fraunhofer Business Unit vision, when we look at this part of Fraunhofer Gesellschaft, for example, so we compare Europe, Asian, American discourse, different strategies, and also some different profile of this company, which is obvious. Fraunhofer tends to present the technological solutions as with this first version, vision as a tool. Because what they do, basically, they offer measurement systems, quality control systems that can do things like inspection of surfaces, very advanced one. So this is the area where visual devices are made for precision, are made to be used as tools. On the other hand, when we look at Hyundai Group and specifically at Boston Dynamics, right now this discourse around this most flamboyant and most visible, most advertised, we know it in the social media, on different platforms, projects of automation and robotics projects of Boston Dynamics. They speak about the new standards for industrial inspection right now. So they speak about safety, industry inspection solutions, that's for what are devices like spot advertised right now, and mobility services, which is natural for for Hyundai Group. Mobility services and mobility infrastructures are the most vital point. So we have the second approach. And when we go to automotive companies like Tesla, for example, there is another, except for vision as a service and mobility services, which are general here, we have another point where vision is a resource, is a data resource. Like we have this proposition which has been debated like in terms of engineering as well, where you have the autonomous Tesla vehicles which are equipped with vision cameras exclusively, like no infrared, no radar, sensor, nor other stuff. And there is a debate, as usual, around this company where the questions are being asked: why not recombining different modes of sensing for these autonomous vehicles? And the replies are different, but one of the points here is that, like with a vision camera, you can accumulate lots of data that are quite useful in terms of marketing goods and services for the customers, okay? For the customers of the company and for the customers that are around, and for the goods and services providers, etc. So it may even go to this interpretation. So in the first case, speaking about Fraunhofer discourse in general, very vaguely, and about Hyundai discourse, the contract, when it comes to some documents they show us, I haven't looked at the proper contracts, I did not have an access to them, but when the question of how to start cooperation is put on the table, so when it comes to the contract and implementation, it starts, which is also quite natural, with the promise of optimization and savings. Like in Fraunhofer, this is very specific. When the products of Fraunhofer Institute are presented, you can say nothing wrong about the company that would like maybe to order it or acquire it or integrate it. The company runs very well. Nevertheless, it needs some minor optimization. So it means, which means that there is a prospect of savings, like you optimize, then your economical result is higher. And it is a kind of conservative, I would say, discourse. Like, it is not to revolutionize your company. We don't want to change a lot, yeah? We want to leave it as it is. It runs very well, although we can give you some solutions that will enhance the productivity of the company, etc. So this is for European version. In this Asian and American version and mobility service, there's a promise, specifically for Boston Dynamics, there's a promise of safety. So it is all about safety right now, which seems somewhat surprising that you build a mobile unit that for the military purpose, at the beginning, we know what the history of Boston Dynamics is, and right now the discourse is all about the promise of safety and the industry inspection solutions that are now being presented as a main reason why to invest in these devices for your industry headquarters is like that. So basically this unit should be programmed to rumble around your factory and read out all the measurements, check out if the lines are functioning well, if everything is fine, and replace, this is the idea, and replace the workers, employees who used to do this. So in both cases, safety and integration policies are being discussed with the owner, which is, again, natural. We will see, it's quite obvious that, well, the company, the agriculture unit, the industry company, the kind of infrastructure for traffic, etc., it is being owned by someone. So you go, if you decide to sign a contract, you have an opportunity to build the new protocols of interaction, the protocols of safety, everything. So it means that the legislation of the ergonomics, etc., everything that is already packed in our, let's say, social security of industry and workplaces, it is a bit behind these ideas and these technologies. So in terms of the protocols, everything is negotiable. So it is going to be discussed by with the owner. That's the line like from Boston Dynamics. The protocols are going to be to cover either the safety measurements or the actual physical areas within which these machines can operate. So in both cases, and with all these three approaches to how to actually market and advertise the autonomous visual systems, there is a promise of seamless integration. That either it is mobile unit that will somehow revolutionize your employment strategies, or set of sensors and solutions that will just improve a bit your infrastructures. We have a seamless integration. And again, this doesn't go also, it doesn't limit only to these two cases. This is somewhat general, feature of this discourse, that the machines can enter quite easily, quite smoothly, like. And that we have this, we have in mind in our studies on the artificial vision and sensory technologies, that we just put the cameras, and there's very complex algorithms behind these cameras, and we have a huge energy power greedy servers somewhere, and that's how it works. Okay? But the integration is seamless. What is, however, again, maybe not on the underlooked, but not very well like pronounced, not strongly pronounced, is that these systems usually need some assistive technologies. Some assistive technologies which are comparable to assistive technologies that we use for inclusion in our society. In public spaces, public buildings, we have lots of regulations that actually encourage us to make the places we work in, the places we live in, accessible for the whole society, including, like, making them inclusive for different types of the problematic situations, referring to the ways that how we move, how we perceive, so also to our sensory apparatus. And the assistive technologies are quite vital, that something I would like to argue for. Also in terms of implementation of technologized sensory. So technologized sensory can be very, like, we can imagine it and we can like build this mythology around it. In terms it is very precise, very quick, very sharp, etc., etc. A-human, anti-human. But at the time, it needs this assistance from the area which is put in front of the camera, in front of the sensor. So this is the moment when designers come to the stage. Exactly. Yeah? Since you need some arrangement outside, you have a space where designers can interfere with algorithms, since the algorithmic gaze relies on assistive technology, and it would be one point. And another one, it would be that the spectral signatures, which is quite hermeneutic term, maybe I will come to this and try to explain it. Spectral signature arrangement is also one of the ways how to manage these systems. So let's start again in terms of seamless integration and assistive technologies. Let's start from the poster. Like if we have a general, I don't know, entry on a technology blog or advertisement or a poster that's speaking, like in this case, about like for the postal services can be quite easily automated. We get pictures like this, lots of units in an open space, and we can imagine some Fordian systems where iterative, mindless labor is being performed, etc. And we immediately also recognize this, that this picture contains everything, and although it does not put on the first plane, plan what might be a kind of technicality of technicality right now. So on the second plan, which I mean by this, I mean all these tiny little marks and signs that are here and there scattered around. All these details like colors, surfaces, lines, barriers, markers, fiducial signs, etc., etc. And then also materials that actually are being used to construct this kind of infrastructure. So when we go to the research, these images are like way less maybe colorful and explanatory. When we look at the illustration in a technical proposition here, I refer to one of the papers, one of the many papers that propose a vehicle positioning system for the logistic warehouse, and the paper is even quite like 1 decade old. So this propositions tend to turn out and be present somewhere in this technical discourse for years. This one has been like prepared by Hagen, Brostel, and his co-researchers from, again, Fraunhofer Institute of Factory Operation and Automation, Magdeburg, in Magdeburg, Germany. So this is an image that shows the warehouse in a part of the warehouse in bird's eye view, where we have a vehicle, a forklift, something like banal vehicle on the left, which has been marked with a tag, with a machine-readable tag, to make it easy to be tracked by the surveillance cameras that have been pre-installed in this warehouse. So this is very, again, this is this example of the conservative, like, let's say, intervention, or the conservative design Fraunhofer can offer. Like, if you need to improve tracking systems for the mobile units in your warehouse, it can be done simply by using what you already have, which means a camera surveillance system, which is usually quite poor, low res, doesn't work on, I don't know, high levels, no filters like ER, UV, whatever. But you can simply find a way just by preparing a planar image markers that are machine-readable markers. Like, the machine can read it very simply, and we all know this kind with all these QR codes, barcodes, etc. So we have this assistive technologies and this layer of the markers that can be adjusted to the qualities of the surveillance systems, of the camera, of sensory systems that we already have, because they make things simpler. So when we follow on with this, with illustrations from this paper, it is actually, this is a report from the warehouses of one of the biggest logistics companies worldwide, operating in Germany, where this system has been installed just to check if it really works. Like, if you can do this tracking so easily. And also here, I would like to mention that especially in these European publications, you hear lots of, there's often an argument for making such an unsophisticated, like, crude solutions. It is energy saving. You just don't need to pre-install everything. You just don't not always, you can also obviously put an RFID tag marker and another, but you tend to do this as low energy as it is possible. So the vision has got this attitude to some point, and these solutions have. What happens here in terms of, like, let's go back to this theoretical discourse. We can paraphrase some lines from Electromagnetic Situations by Gordon Savicic and Brent Sjolen. And put it something like this, like when assistive technologies are being pre-installed, what has been before an unintentional emanation to the visual field, like things are visible, that's all, from the surfaces, and like captured by machine learning models, now is replaced with intentional transmissions from the surfaces. That's what I tried to do this trick. Like, it was emanation, now it becomes transmission. Yeah? So the visual field was as it was, just machines and programmers have to guess it, and then we have signs. And these assistive technologies, when we look at this in that way, is no more like secondary technical stuff. It becomes valid in terms of like communication, machine-readable signs. And again, when we go back to the studies on these planar markers, passive markers, these like secondary derivatives of this business of automated vision, we got lots of projects actually that we can track since like April Tax project by Olszewska, somewhere 2011. Here I got like 3 examples from one of the papers from 2020. And when you go through this research and through this literature, you're going to find more and more and more of these, which are basically sets of signs made on the according to this let's say recipe or that we have for QR codes and barcodes. But then when you look into the research, you realize that there are lots of limitations that you have to observe once you plan to put these markers in a physical environment and make it readable to the machines that move actually. So the light can change, the angle of view can change, etc., etc. The resolution of a camera can be different. And there are suddenly this instability of the field of vision turns out to be very, very obtrusive, I would say. So there is lots of issues to be solved, even with this, the simple shapes and the forms that we actually design for the machines. But it is not only about marks, tags, fiducial signs. It is also, and this is the second argument why when designing can enter this algorithmic business and unbalance it, not only by making tags, but also by using and recombining proper materials. This is something that I already mentioned, like we have this is actually military concealment technologies coined this phrase, like spectral signature management. What does it mean? You can also read about the emissivity design, for example. You have a possibility to design. Here I put marks and signs again, but it relates especially for military design, for concealments to like textiles and concealment techniques in general. Yeah, you can recombine materials and signs that are either visible or invisible in different spectral ranges. So here, one of the studies we have, like James Snyder at Consortes 2018 for American road systems, getting prepared for autonomous vehicles, autonomous driving, and again, to read a traditional sign, traffic sign, you need to, obviously it is possible, and they do this, like train a model, a mathematical model that will recognize it. And again, we have all these issues with change of color, etc., illumination and all. So then you can think about, okay, maybe let's simplify it. So let's make a specific machine-readable sign. And if we, and this is the proposition coming from this paper, if we recombine materials in that way that we put on this side, on this sign, which is visual spectrum visible, a layer of emissive emulsion, which is responsive to near infrared spectrum, then near infrared camera will read this sign, which is on the top of something that we see. So the visual camera will read in, or human will read in one spectrum, the near infrared will take it in another. And this is but one example, but there are lots of studies actually that show us how these materials that have been actually around for years, because like this thermal design with glazes and films and coatings that we put on the glass in the windows to save the energy, for example, or how we recombine low emissive paints for energy saving. How this can be, all this material engineering can be also used accidentally or in purpose, used for visual inspection. So we can travel around, like look at the spectrum look at the electromagnetic spectrum and say, hey, we got different types of cameras, like visible, ultraviolet, near infrared, far infrared, where thermal ER. So we can then think about it for a second, like we can compose and recombine materials in the way, okay, so now I want to make something visible. The concealment, military concealment is one story, and making things visible is another one. Visible in IR, because for some purpose, I want to make a visual accent in IR, like visual. Like send a signal in near infrared or in thermal camera, etc. So then you start to think not only about like assistive technologies in terms of like passive markers and machine-readable signs, but you start to think about surfaces, materials, and chemical compositions as well. So we move on and on. Okay, but we may say, of course, however, yeah, well, I'm talking here at length about all this stuff, yeah. However, I said it is unlikely to happen. Why? I would give like this is going to be short digression. This research, this kind of research and this kind of technical propositions, usually, as we kind of sense it, is of minor impact. So I'm not like presenting you the well-known papers, and there is not a large theory behind it, not a large strategy, not something that is well known. It is rather a kind of like, I would say, a modest collection of ideas that come from different parts of like design and technology, some from technical departments of science and technology, university, system engineering. Some authors are with the design background, architecture, etc., etc. So it is here, there, a little bit ad hoc research, who cares? These are just signs and marks. After all, the large AI model will come and phase it out. Like, might be, but also the time this, so we stay with her, however, a digression is that, like, we have a minor impact propositions. So this is what I said. we have also designers that tend to work in highly commodified environment. Because when I can imagine, when you are a designer, you have your services, you provide some services, for example, for a hotel owner or for a company that wish to like design a new product, and this is business situation. Yeah, you enter this commodification game, and then you prepare your design according to agreement with the client. So you negotiate all the policies together, and then yeah, you are already you're not doing it usually with in a subversive way, but you need to fit in what has already been said, produced, happened, what is demanded in terms of the marketplace, etc. So then you have this small, I will keep on showing maybe one or two more of these minor projects. So these minor projects are designers' projects, and for example here we have a propositions of two young researchers, designers who at the time were somehow collaborating with re-established or newly established Bauhaus Academy, that say, okay, we can customize this procedure of planar markings. So here, what you have here, you have the same systems as we've seen in a moment before with QR tags and marks, but made in a way that actually will fit into specific objects. So you can design an object with a tag and make such a specific custom-made object visible and let's say available for identification for a machine vision system that can operate, I don't know, anyway. So then think about the commodification possibilities that are behind it. You can do actually wonderful stuff for the luxury goods, customized made luxury goods, and then track the history of these goods for your company with every camera system, maybe. Yeah. However, this is highly commodified system. And maybe it is like this, all these low impact studies, they sit also in the area that actually when we look at this, remind us of the history that we've been taught at academia, at school, when it goes to the history of design, history of information design, Maldonado, Bonsiepe, and the systems of science and communication, very famous debates that was around in European universities, how to devise a system that would communicate independently of language with the users of a machine. These are examples for the interface of Olivetti, ELEA computer, or medical machines that Bonsiepe and Maldonado, descendants of Bauhaus working for the Ulm School of Design, yeah, have proposed in the 60s. When we look at this history of markers, planners, and machine-related designs, that what comes first is a specific approach to what is happening around, which actually can be somehow expressed in this quote from Martin Krampen. Krampen was also an alumni of Ulm School of Design, so Maldonado, Bonsiepe, working in United States and Canada. And he has been involved at some point also in the research or consortium who has been built in order to systematize the traffic sign systems. So it is not about interface in the computers, ALEA, but sign system. So what Krampen said, when environmental problems arise, produced by technological or other developments, signs or symbols are created, often anonymously, and tentatively to communicate about these problems. So the sequence is like that we have a technology entering environment, and then the new signs and symbols, and they are messy. This is part of his research. They are messy. Then you need to call the United Nations Consortium to sit in Vienna or in Paris to debate how to optimize these science systems, and then they will come with the protocol. Okay? But the thing is that the technology is first, and then comes the design. Then comes the designer. So this is this digression about the 20th century. Low impact project and the history of this, let's say, profession and approaches that have been applied in design. And let's go back for a second, to these low impact projects again. This is a picture, like another illustration which I like very much. This time from the paper on linking physical objects to their digital twins. Again, fiducial markers. But it's more elaborated in this concept, which has been presented by the authors, where they say, okay, let's look at Tokyo cityscape, and let's think about how these systems can work in the highly saturated visual environment, where there's lots of signals, lots of things are changing, the color and light. And at one point, this environment is totally artificial, and another point is that, okay, we may hide within these spaces, and this is also the project of the seed mark. Hide like tags and planar markers that are machine readable only. This is one thing, and sometimes we cannot. What is called in this approach, they are unobtrusive towards the human spectators. So we don't even see it is a marker. Like either it is invisible in visual spectrum, or we don't even see, because like it's so well integrated to everything that is around, like it hides away. And now think again, what does it mean? When you have companies that provide you some services, yeah, and they have their own protocols of communication, and you have also designers and designers' clients who like function within the real environment, like running a shop or a cafe or a hotel. Hotels are a very good example. There are at a set, like 8 years ago, I don't know, there was a series of paper by a research group recombined from designers and architects from Technology and Design University of Singapore, MIT, and Tokyo Denki University, Japan, that actually set a challenge for machine or robot-inclusive environments. Speaking like, come on, if you make if you plan to put these machines, autonomous machines in hotels or hospitals for some reason, you need to design this environment so that these machines could work with this in terms of like again, mirrors or opaque structures, like how you structure this, how they gonna function within this environment. This is one question, and another one is like, and another thing that actually turns up when you come across again such a niche study is that, okay, in highly technologized environments, like in Singapore, for example, you already have these studies. Like someone is thinking about it. Okay, since we have all these commodities and they function, so then you see the first on the run are not only factories like in Europe, but also hotels, for example, or hospitals. And then you go. So this was this. However, and from however we slowly move to the last point, which is unless. So however, these studies are like extremely niche, specific. They come from different backgrounds. They not form into one the core discourse. There is no theory behind this. And there are like low impact propositions also, I would say, because also for the reason that design comes after technology. So this is this trait of Ulm school. Design comes after technology. So if I were to like go to this last part of my thesis and rework it. So again, if I were to express my thesis, it would be like designers have some power to counterbalance the hegemony of data capital, AI-based capital. But it is unlikely to happen, I've put some arguments for this, unless design anticipates technologies. Which is algorithms, as Andreevich and others put it, are preemptive in their nature. So in the observation of patterns of life, there is a mechanism of preemption. So the mathematical model needs to assume something that it will happen. So so on the side of algorithmic procedures, there is a preemption. And on the side of like design procedures, we get anticipation. We anticipate this is the core of this methodology. We anticipate what the room is going to be used for, what the space is going to be used for, yeah? What are our body dimensions, etc., etc. We anticipate. Maybe Krampen and Ulm School failed when they agree that signs come after technology. And maybe signals, well, not maybe, it is like signals come before cameras are set in natural environment. All the signals comes before cameras are set. So then, and we go to this very practical aim of my talk, maybe it would make sense to put into the curriculum of art and design, not maybe the whole course, but some workshops here and there, or some propositions that would take an entry on assistive technologies and material design in terms of like technological sensing specifically. Because then if maybe we would have in this system, in this situation, maybe we would gain a kind of tactics that is a bit specialized. It's specific for some piece of technologies, but this is something different than like fostering healthy paranoia, like for critical engineering, wonderful proposition, by the way, or like practices of like self-organization, because they come after things happen. It also might be a devilish proposition because we cannot control ourselves. We all professionals in design and art, we enter in their way with their ethics within this environment, so it can work on a different side. But nonetheless, anticipation would make this possibility of outbalancing what is happening in the algorithmic area maybe a bit more probable. Which is my question also to you, how you find such an idea feasible or completely utopian. Thank you for listening.